Welcome back. So I think it's time to make another video. I've been working a bit off screen, so let's take a look at what I have done. Let's do it like this. So let me just add a couple of more commits so we're sure we got everything. One more time. 10 commits. How many commits have I made? Okay, here we go. So I think in this commit we started tracking objects, right? And then in this commit that I did off screen, we now free objects when the VM exits. So there's some code here that's called when you exit. Then I add a string in turning, which is just every time you make a string, it sees if that string has already been made as a constant. And if it has been made, we don't make it again. So basically you reuse old strings. Then I added support for print statements. There's nothing super interesting about that. Simply a new operator, a new operation that when consumed it will print the top of the stack. Then there is global variable definition. The main thing here is that global variables are stored in a hash map in the VM. See if I can find that. Can I close this? No. Close this. No. Let's say vm.odin. So here there's a new hash map of global values where they are stored by name. And so this commit was just defining them, which puts them into the map. This one lets us read the global variables. Then I simply added support in the disassembler so that define global and read global is printed correctly. Then I had added some interning for variable declarations, but I decided to remove that because of the way the REPL works. It didn't play so well with that. Then finally I added some code that lets us assign to variables. So the difference is that you can say variable a equals 2, but that is called defining a global, but then I also added support for assigning, which is like this, setting a value of something that already exists. And then we can print it. We get back the disassembly, but we also get the value here. All right, so that's about it. So let's move on. The next thing we're going to look at is local variables. Okay, so the tricky thing about local variables is that we have to handle their lifetime. So for example, here we have a bunch of nested blocks, and when this block closes, this variable should kind of die. And the way we handle that is by putting them on the stack. It's also what, if you ever tried assembly, it's also what happens in assembly. Normally is you put local variables on the stack. So we'll do the same, but it's the stack of the VM instead of the hardware stack. So to begin with, we're going to add a new struct. So let's do that. Probably here in the compiler. We'll add it at the top. We will add a new struct that is also called the compiler. So let me disable Copilot. We want some locals, and that is supposed to be an array of something called a local, which we haven't defined yet. Then there's a local count, which is an integer. There's a scope depth, which is also an integer. And that's about it. Not sure what we should put here. I'm not sure what this uint is. Okay, so the way we're going to keep track of scoping was, if you remember in the interpreter, we had these nested hash maps, but we're not going to do this here. We're just going to keep track of kind of a level. I had a similar idea that we could have done that in the Rust code as well. That might be a little bit more natural there. But all right, let's do this. So okay, so let's initialize the compiler. Compiler is a compiler, and don't we have an init parser? Apparently we don't. We have the init tokenizer. No, but anyway, we'll make an init compiler, and we can make it take a pointer, I guess, similar to what he's doing. So let's say compiler local count 0, scope depth 0, and it says current, which is interesting. I suppose we can put this as nil as well. And then let's add a type annotation. There we go. Let's see if it compiles. It does compile, so we didn't do anything too crazy. Right, and then we have here in a tokenizer, and let's make a compiler. And then let's init it. So is it like this? I already forgot. Seems to be fine. Yes. All right. So let us add block statements. So we already support print and then expression statements, but now we'll say if we match left brace, then it's a block statement. So we'll say begin scope, block, and scope. And that's it for now. Let's do the block thing. So as long as we don't see a write brace and it's also not in the file, then we have to pass a declaration. And then the final thing is we need there to be a write brace. Expected this thing after block. And that's it. So we also need these begin scope, which will modify the compiler, and end scope. Be surprised if it's not oops. This. Let's check out that it still compiles. So it does not compile. Because there's no while, first of all. It's just for. And legal use of selector shorthand. Right. Okay, so let's get started on handling local variable declarations. So we already have some code for passing variables, but it's like assumes everything is a global variable. So let's change it. So we need to declare a variable. So that will put it into the compiler. Let it store. Let it store where it, like at what level it was declared. Sorry, so I'm a bit tired. So I've changed this a bit so it also returns a string. I'm not sure if it really needs that anymore, but just to keep it. Okay, so basically we're exiting here because we don't want to put something in the constant table because we're storing local variables on the stack. So anyway, so define variable. Here's a procedure and kind of the same thing if we are defining a local variable, we don't do anything. Okay, we need this declare variable function. And if it is a global variable, we don't do anything because it's handled a different way. Otherwise, we'll get the name from the previous token. And then we'll add that here. So let's write that function, take the name, which is a token, and it will make a local. So we look in the compiler, the local counts. We have to remember to afterwards increment this thing. Then the name is the name and the depth is the current depth. So we need to change something because here we just have a dynamic array. Let's change it to be this. So we have some kind of buffer. All right. Okay, but now that we have a buffer, we should also check. Let's actually, instead of this, let's make it like max locals. And we'll do that here. Max locals. That should work. So we'll throw an error, too many local variables. remember to return after that. Okay, so now we need to add some error handling if you try to override a local variable. So how do for loops work? Okay, so for I in would that work? I don't know. So let's say I equals current local count minus 1. And we'll say for I greater equals 0. We're gonna get this local. We are going to check its depth and if we get to a local that's in a different scope, we can already break out. But otherwise, we have to check if the identifiers are equal. So this name that we're trying to assign now and that name, we will throw an error. So let's add this identifiers equal function, which will take two tokens. Let's call them A and B, similar to him. Let me just remember. I think we have to say legseam.length, or is it like length, like that? And probably we should return Boolean. So if they're not equal, we return false. Otherwise, we can do a compare, but let's say for I and 0 to length of this legseam, say if A legseam I doesn't equal B legseam I, we can return false. But otherwise we have to return true. Okay, and now it looks like the interesting thing happens. So how do the locals like disappear when you exit a scope? Well, we do that in this endScope function. So we'll say here for current local count greater than 0 and current locals current local count minus 1 depth greater than the current scope depth. So basically everything, the current scope, we're gonna emit a pop operation Then we'll decrement this guy. Let me look at this emit byte. Yeah, I have to cast it. So where did it go? In scope. To cast it to a U8. Let's see if this compiles now. It did not. Compile. It have to be opcode. vm.opcode, yes. Okay, 356, there's something here. We have to say explicitly that we are not going all the way, we're just going here. Okay, and it compiles. Let's actually try to see what happens if we do something with this. And then we can say print a. It probably will not work. Yeah, so let's see. So first we define a constant 0, and that's a string that has the data 97, which is, we know is the ASCII code for A. Then we define constant 1, which is a number equal to 2. Then we define a global. Then we define the second constant, which is this guy. Then here it thinks it has to get a global. It doesn't know how to get a local variable, which is why the next chapter is called, or the next section is called using locals. But then we call print on the result of this thing. So it prints 2, the global value. Then afterwards we get the global and we call print, so it prints 2 again. Okay, but at least it didn't explode, so I think that's a success. I think that's it for this video. In the next one we'll try to actually use locals. Bye bye.